Hello everyone, welcome back to the channel. Today we are going to solve this problem related to the topic solution of a triangle, and here we are given a quadrilateral PQRS in which two of its angles are equal and is 70 degree. One of its side is 1 unit and the other angles are given here. We need to find out the value of 4 alpha beta sine theta. Right, alpha and beta are the sides of the quadrilateral and there is an angle RPS theta. We need to find the value of 4 alpha beta sine theta using all the details here. So at first let's make the figure related to this quadrilateral. So after making this figure here, we can do some calculations within the figure first of all. But why are we going to do that? Let's try to understand the background. We are asked to find out the value of 4 alpha beta sine theta. Okay, alpha and beta are the sides, theta is an angle. So we can relate side and angle only by sine law or like cosine law. But in cosine law, there is involvement of squares of the sides. So probably cosine law may not help us here. However, we might be able to use the sine law, and for that we need to solve the triangle at first. Okay, here are various number of triangles. We need to solve that. From which part it would be easier. So sine of theta, it means it would be better if we have a value of side RS, right? In triangle PSR. Let's try to find out some other angular details within the figure. So this angle is 70 minus 15. It's 55 degree, right? This angle would be 30 degree. And then if this is 55, this is whole 70, we can find out this angle. 180 minus 70, 110, 110 minus 55 is 55. Okay, now something interesting popped out. We have in triangle QRS, two of its angles are equal. That means QR and RS is same value, 1. They both are 1 because QRS came out to be isosceles triangle. So now we have side corresponding to theta, right? Similarly, we have angle corresponding to beta as 40 degree, or in small triangle we have 15 degree as well, right? See here, it's up to us which triangle to use. Okay, now, oh, another easy thing here, angle opposite to side alpha is 30 degree. That means sine 30 is a very good value, right? We have direct value, less use of calculator. Similarly, another angle opposite to alpha would be this one, but it would be very difficult for us to find this particular angle here. So let's leave it now. Let's begin the calculation. In triangle PSR, right? In triangle PSR, let's use the sine law. RS by angle RPS is equal to PS by angle PRS. Right? I think with this expression we can relate theta and beta. Or RS we have it's 1, RPS it's sine theta, PS is beta PRS is sine 40 degree. Oh, it looks little bit tedious to know the value of sine 40, right? But let's keep it as it is. So beta sine theta is sine 40 degree. This is from the equation, right? Let's use another triangle. Can we relate theta and alpha? Probably not. If we relate alpha and beta, we may not find their product, or we may just relate them, but still we do not have this angle to relate alpha and beta in this smaller triangle. So let's find out alpha only, because we have lots of angles here. In triangle QRP we have many angles, like both of the angles are known. We might find the value of alpha here. In triangle QRP, again using sine law, alpha by sine 30 degree equals to, right, alpha by sine 30 is equals to, oh, we may get this angle right here, because one is known. So let's try to find out this angle at first. We have this whole angle 70, this angle to be 30, 70, 30, 100, 180 minus 100 is 80 degree. Okay. Oh, now we may see some connection here. This angle came out to be 80. So alpha by sine 30 equals to 1 by sine 80, or alpha equals to sine 30 is 1 by 2, so it is 1 by 2 sine 80. This is second equation. Now let's find out 4 alpha beta sine theta. We have 4, alpha is 1 by 2 sine 80. We have beta sine theta sine 40 is equals to 2 to cancel out, 2 sine 40 divided by sine 80. Let's use 2 sine 40 divided by 2 sine 40 cos 40, right? So 2 sine 40, 2 sine 40 gets cancel out. We are left with cos 40. That is 4 alpha beta sine theta equals to sec 40. So 4 alpha beta sine theta has the value of sec 40. This is the solution. But we still have to choose the option here. We need to check where the value of 4 alpha beta sine theta might lie. Here it is or R. So we can have multiple correct answers as well. To analyze it, let's write which known values we know about sec. We might know sec 30, we might know sec 45. Sec 30 is 2 by root 3. Sec 45 is root 2, right? 2 by 1.7 something, and root 2 is 1.41 something, right? So this is 1.1 something, and we have 1.41 something. So our value sec 40 lies between 1.1 something to 1.41 something. our value lies within this interval. Now, what are our options? 1.1 to 1.41, right? This is our analytical interval that we just found out. So this can lie, the value can lie between A, this value can lie between in the intervals in B, right? Root 2 is 1.41 already. So not in the C. Now not in the root 2, it's already multiplied by 2. So not in the interval D. Hence the answer is A and B.